Okay, so now we look at, give you another example regarding the application of triple integral. So now we look at this question. Okay, a solid is bounded below the sphere. Okay, so you have a sphere. So this is extra example. So you have x squared plus y squared plus z squared equal to 4z. Looks like you have to do the completing the square for this. Okay, so when we do the completing the square for the z, and we got this one, so we obtain that we have a sphere with radius 2 and centered at 0, 0, 2. Okay, and from the instruction given here, the solid is bounded below the sphere and above the cone. Okay, so meaning that above the cone and below the sphere. So we have to erase the unwanted solid. Okay, above the cone, and below the sphere. Okay, so that is our solid. It is ice cream cone-like surface. Right? But your center is not your sphere is not centered at the origin. So meaning that your row, if you solve this using spherical coordinate, then the row is not constant because your sphere is shifted somewhere along the z equal to 2. Okay, so now the question here give you density function is 1 over z squared, and mass also given, and you have to find the z bar, which is the z coordinate of the center of gravity of the solid. Okay, so you have to find the only z bar, not the x bar, not the y bar, but only z bar, which is the center of the mass of the solid. Okay, so mass is given, so we don't need to compute that. So now the formula to get the z bar is moment of mass xy over the mass. So mass is given, so we only have to find the moment of mass with respect to xy plane. So using triple integral, so you have to multiply by z, and the density function is 1 over z squared dv. Okay, so in this case we use the spherical coordinate. So rho square sine phi d rho d phi d theta. So we have to convert the z is 1 over rho cos phi, and then rho squared sine phi d rho d phi d theta. Okay, then we simplify this, so we have rho tangent phi d rho d phi d theta. So now we want to get the limit of theta. So basically from the graph, so now theta, we have a complete circle where you can see this one, right, as on the xy plane. So 0 to pi, and then phi is you can see this one, your solid is part of the phi, and the phi is depending on the cone that you have here, where the phi is 0 to pi over 4. Okay, now you need to get the row. So row here, if you want to know the limit of the row, so we have to sketch the line starting from the origin. So you can see that the row is 0. The row is 0, but your upper bound of row is not a row equal to 2 or row equal to 4 because it is shifted. Remember, I told you if you have ice cream cone-like surface and your ice cream is coming from the sphere centered at the origin, and your row will be constant, but this one is not centered at the origin, shifted somewhere. So then you have to use, how can you find the equation? You have to find this. Your row, your limit of the row, the upper bound of the row should be a function, depends on the curve of this sphere. So you need to do something there. So now what we can see, what we can do from this equation. So x squared y squared z minus 2 square equal to 4. So then we need to use the original expression, so x squared, because we want to replace the Cartesian equation into spherical equation. So x squared plus y squared plus z squared equal to 4z. Okay, so we have, it looks like this one is what? This is rho squared, right? Rho squared equal to 4, and z is rho cos phi. So then we can factorize rho squared minus 4 rho cos phi equal to 0, and factorize. So we will get rho minus 4 cos phi equal to 0, and we got rho equal to 0 and rho equal to 4 cos phi. Okay, so now rho 0 is, as you can see, rho 0 is the origin, and meaning that this surface, which is given by the sphere shifted along the z, is given by rho equal to 4 cos phi. So now we know the equation upper bound here is in terms of spherical, in terms of rho, so rho equal to 4 cos phi. 4 cos phi. So now we plug in the limit into our triple integral. So 0 to pi, 0 to pi over 4, 0 to what we got is now 4 cos phi. Okay, then we can integrate. Okay, first we integrate the rho. So tangent phi, then you have rho squared over 2, 0 to 4 cos phi d theta. Then maybe I have to just replace back tangent is because there is cos there, sine cos phi, and then I can put the 1 over 2 upside, so 16 cos square phi minus 0. Okay, so I think so d phi d theta, and then I can simplify this one to be 8. So sine phi cos phi d theta. And you can use the substitution method. So I'm not going to finish this off. So I will give you the solution. Okay, by using substitution, and you do some steps there, and the answer is 4 pi. So this is mass. Okay. Only the moment of mass, but we are looking for the z bar, right? And then we substitute the into the formula. So into the formula here, so then we have 4 pi divided by, so the mass is 4 pi ln 2. So the answer is 1 over ln 2. Okay, so find z bar. So we done that. The answer is 1 over ln 2.